Hello, everyone. Thank you for tuning in once again. And we want to welcome you to the series of interview podcasts at amazic.com, where we talk to industry influencers from various companies that work with Kubernetes, cloud native, and in that ecosystem. And we have a lot more interviews like this. They're all on amazic.com. So if you could head over there, you'll find a lot of good stuff. We've got interviews, we've got articles. I write a lot of articles there. There are job listings. There's also event coverage. We cover events like KubeCon, HashiConf, a whole bunch of other happening events in the space. So if you're interested and you want to follow what's the latest, what's happening, definitely head over to amazic.com. We have with us today a special guest who's from Noname Security. His name is Filip Verloy. He's the technical evangelist at Noname. So Filip, we want to welcome you. Thank you so much for joining us today.
Yeah, thank you for having me. It's a pleasure to be here.
Great. So Filip, if you could tell us a bit about yourself to get started. What have you been up to, before Noname Security? What's your background like? If you could just start with that.
Yeah, absolutely. So I've been in the IT industry for over 20 years now. Wow. So that's a long time. I started on the customer side as a system administrator, working mostly on Sun Microsystems equipment. Then I moved into consulting for a number of years because I sort of saw that the new and interesting projects were always handled by consultants, not so much the in-house staff. So that's why I jumped into consulting. Mm-hmm. So I mostly did pre-sales. And then since the last 15 years or so, I've been working for various vendors. So VMware, Citrix, Riverbed. I joined a cloud data management startup called Rubrik. I was there for 5.5 years as the field CTO. And then for the last 6 months, I've been at Noname Security as the technical evangelist. So I basically work with customers and partners to try to increase their API security posture.
That's awesome. That's awesome. So so that's going to be our topic today that you just mentioned, API security. And that's what Noname Security specializes in. We're going to talk all about that today, and we'd love to hear your thoughts on it. So to get started, I'd like us to talk about just API attacks. What are some of the notable ones that have been in the news in recent times? And what are some of the things that we could take away from those news articles, from what these organizations did or didn't do that made them victims to these attacks? Just talk about API attacks in the news, if you will.
Yeah, sure. So a fairly recent one was Coinbase. So that was February of this year. Mm-hmm. So the reason that they had an issue is they had a flaw in Coinbase trading interface. Okay. So the underlying cause really was a bug in the logic validation. Mm-hmm. So the idea is they had a trading API endpoint where traders could launch trades for specific cryptocurrencies. So the idea is you can submit a trade to a specific order book. Mm-hmm. And what happened here is that they didn't really check the source account. So the way it worked was you had a user with two accounts. In one account, they held cheap cryptocurrency, let's say Chibu Inu, and a second account, they held a more expensive cryptocurrency like Bitcoin. Mm-hmm. What they did is they submitted a market order to the Bitcoin US dollar order book to sell, let's say, 100 Bitcoin. Whoa. But before they launched the order, they manually edited the API request. And instead of specifying their Bitcoin account, they specified their Shiba Inu account with a cheaper cryptocurrency. There was still validation on the side of Coinbase. So they validated, yes, this person has 100 of this cryptocurrency, but they forgot to check if it was the matching cryptocurrency. So they did not check again for Bitcoin versus Shiba Inu. They just checked for the number 100. So this way, this person was able to sell 100 Bitcoin for the price of 100 Shiba Inu. So that was a very unfortunate event for Coinbase, a fortunate event for this researcher. Actually, this person did not really take advantage of it. He disclosed it using, I think, HackerOne for a bug bounty. But these types of logic validation issues, that's typically what we see more and more these days. And it's hard to defend against as a company, right? Because you might have a perfectly written API, but depending on how the backend sort of operates, we do see a lot of issues with validating those inputs and those kinds of stacked inputs as well. So it happens all of the time. There's other notable ones like Peloton, which is one that's quoted a lot in public. So the exercise bike company Peloton, I believe even US President Biden uses Peloton. So the idea is they had an unauthenticated API that you could query and just get all of this personal information back from, which is, not what you want. If I can sort of understand who is using Peloton, how their health is changing over time, for example, things like that. That's not the best thing. So those things they happen all of the time. I think the problem with APIs, or what can a company do about it? The problem is there's little commonality between these API attacks. Meaning,
could we hold on to that thought for a bit, because we'll get to that soon. But the solution to this, we'll get to that. But I just wanted to dig in a little more and ask, so these that you mentioned are not necessarily attacks; they're more lapses, right? They're more like vulnerabilities from the inside. So it's interesting that and in fact, probably more than attacks, this is more common, right? Someone forgets to secure something the right way in the API, and then that becomes a vulnerability. That's probably more common than an attack, right? Would you say that?
Yeah. So if you look at, for example, OWASP has this list of the OWASP API top 10 vulnerabilities, and a lot of these vulnerabilities are indeed things like, they forgot to implement decent authentication, they did not check authorization in a specific way or a very meaningful way. So there are sort of misconfiguration type of situations where you can simply walk through the front door of the API, so to speak, and query the information that you want to get back. But then there's also more sophisticated, quote unquote, real attacks as well, where they go after the manipulation of the business logic. So it's those two that we see combined a lot.
Yeah. Wow. Could you talk a bit about just the life cycle of an API vulnerability or attack? How it starts, how it progresses, when do people actually find out, after how long do they find out, what's the potential impact? You've given us some good examples, but if you could sort of trace it back a bit to where, it starts and how it progresses, and sort of tell us about the life cycle, that'll be great.
Sure. So this is actually an interesting one, because it really speaks to the heart of the difference between a traditional web application attack, I should say, and a more complicated or a more involved API type logic attack that we see these days. So for a traditional web application attack, you can typically use like signature-based blocking tools, web application firewall. So those tools are great at stopping, high-frequency requests, or blocking a system that generates a lot of request failures, for example, things like that. So if you're going after, SQL injection, cross-site scripting, these are these typical one and done type of attacks. So when you talk about how long does it take, these are typically people that launch an attack against your web application, and they either get in or they don't get in. For APIs, it's typically more different in a sense that the more sophisticated ones, they try to determine the logic that's offered by the application. The application is then accessible via the API, and those are typically more in the low and slow type of scenario. So if I make a request to a certain API, I get a response back. What can I learn from this response? So this is more of an attack that takes a longer time, because you really have to investigate, how is this application responding back to me? What can I do with this piece of information that I now learned from doing a GET request to a certain endpoint, can I take that as an input to talk to another API endpoint, for example? So these attacks typically take longer. And the idea then is you have to take those learnings as an attacker and then implement them or use them in sort of your next step to gain further access into the system. So that's something that we see a lot. Or you just misuse badly implemented, authorization, or even sometimes lack of authentication. So it's usually a combination of those attacks. So it's not really a scenario where you can say, oh, a typical attack takes hours or weeks. It really depends on how open your front door is. In a more traditional web type of attack, it's really quick. Like I said, one and done. But for APIs, it takes some investigation and takes some time, and it's much more thought out.
Okay, interesting. If you could follow up on that, talking about just these so developers obviously want to build APIs fast, enable more functionality in their applications, but in this push to like move faster, release more frequently, obviously stuff gets forgotten, misconfigured. If I'd like to talk to you about just how kind of getting into the solution part, how do we meet these two goals of making sure that APIs can be built fast and released fast, at the same time that security is not left out of that whole process? How can you meet both these goals as thinking of it from a developer as well as from the operator's perspective?
Yeah, sure. So developers, they need to move fast, as you say. And that's what they should do because of the competitive nature of business, right? So we are all competing on this global stage organizationally. So the business is sort of forcing them to move as quickly as possible. So the idea is, if you want to then include good security hygiene as part of the development process, we need to make that as seamless as possible.
Okay.
So I think from a best practices perspective, there are like a whole slew of baseline security best practices we can implement for APIs. Okay. So we can validate APIs that they are building before releasing them into production. The idea is we want to point out any blind spots that still exist and then show developers how to mitigate these blind spots. So the only way I think this works is you have to make this part of their existing workflow. So in our case, the idea is we want to integrate security validation into their existing CI/CD pipelines and offer the remediation action from their existing toolset. So if they're using Azure DevOps, or they're using Jenkins, or they're using Circle CI or tools like that, they shouldn't be forced to jump out of those tools and jump out of that context to understand what the security posture of the API is that they're building. So to some extent, I think APIs are like cats, and you want them to be like cats because cats are unique and they're very creative. But the problem is you cannot have all of the cats walk in the same direction. Like, it's very hard to tell cats exactly what to do. It's also very hard to tell developers exactly what to do. So the focus should be on sneaking in those security best practices to a certain extent, make it as unintrusive as possible, but just make it part of their natural workflow so you're not disturbing their rhythm, so to speak. As a quick example, I saw a session from AWS Reinforce a couple of days ago, and there they pointed out that I believe it was 14%, so 14% of developers list security as a top priority when writing code. So there's a lot of work to be done on the shift left piece to make sure we are pushing out secure code, but at the same time as quickly as humanly possible as well.
So what are some of the one-time tasks that need to be done, maybe initially, to make sure that the APIs that are created are secure? And what are some of the ongoing maintenance stuff that needs to get done, and even how you can kind of automate this maintenance of just securing APIs over the long term. Could you just give us some of the operational perspective? What does it involve?
Yeah, so I think one thing to realize as a security professional or a security operations person is that there's no such thing as a greenfield deployment typically. So even if you're talking to developers, the organization has already APIs in production. So we need to make sure that we understand what those APIs are, who has access to those APIs, how are they configured, and so on. So from a security operations perspective, the initial task, I would say, is to build a full inventory of all of the APIs that are in use. And this is typically a difficult thing to understand, because if we go to a customer from our perspective as Noname, for example, and I'm sure this is true for all of our competitors as well, is we find a lot of unknown APIs in a typical organization. So developers have put in internal APIs with the idea of, oh, I'm going to take away that internal API and I'm going to close that access once we go into production and so on, and then they forget about it or they version it and they leave some things open. So getting a good inventory is a good first step. So that's something that you always have to start with, I think. And then it's about understanding the security posture of your APIs. The idea is, if you look at APIs in production, you have to figure out how are the APIs used in the real world, and can we take learnings from how they are used in the real world and potentially change our API design to get to a higher level of API security posture. So in terms of one-off operations, I think it's more like a loop, kind of like a DevOps loop or a DevSecOps loop, if you will. The idea is we always need to reinforce our learnings from production and bring that back to implementing secure code. And the reason I say that is that, again, each and every API tends to be different. Yes, there are some basic steps that you have to do: implement decent authentication, implement the least privileged access, and so on. So those are design choices that you absolutely have to make. But typically each API is custom built. So the security for those APIs has to take into account that custom business logic. So that's really the difficulty that we're sort of talking about when it comes to API security.
Interesting. And, so all of this is a lot to do, and especially when there's thousands of APIs, it's hard to do it manually. So how do solutions like yours, Noname Security and the others, how do these API security solutions help with this? For example, with the inventory, taking inventory of all your APIs, how does it help? Does it help with that? And then all of this, the feedback loop from production to development. How do API security solutions help with these things?
Yeah, absolutely. So basically what we do in order to establish a full inventory of what you are using is, and this sort of goes back to when we first started talking about things like network virtualization. And in network virtualization, you heard a lot about, north-southbound traffic versus east-westbound traffic. And this is still the case for APIs as well, whereby if you have existing tools, you have web application firewalls, you have API gateways, these are typically used to demark north-south traffic, right? So the traffic that goes external, maybe to your business partners or to consumers, that traffic passes sort of your north-south boundary. But when we talk about creating an inventory, we need to see all of the traffic, even internal traffic. So that's why you need a system that can really take in all kinds of traffic from public cloud sources, from gateways, from internal network devices, combine all of these traffic sources together and sort of filter out API-specific communication there. And that's what we use to build a full inventory. So as long as there is something, and this could be a machine, this could be a user, something talking to an API endpoint, we will see it because it is part of that flow somehow that we are capturing across the entire organization.
Very neat, very neat. Yeah, and what about with, like what you're talking about, the feedback loop from production, other ways that the solutions help with that as well?
Yeah, so what we can do is basically our platform sort of consists of three pillars, if I can call it like that. So we have the testing pillar, which is sort of step one. How can we help developers implement secure code? Then we have posture management and runtime security. What we can do is we can take that runtime security piece, so all of the actual real-time network traffic, and use that as an input for the testing module. So we can see the actual consumption of the APIs. We can use that as a description of how we feel the API works and put that into the testing suite. So we can now validate the security of that system without forcing the developer to create documentation, create things like a Swagger file, a set of curl commands, something that describes the API is then uploaded to our system and we will validate it. Of course, we can do that as well. But we can also take our production system as input for the testing engine as well. So that's why this sort of loop is sort of self-reinforcing, if you will.
So to understand, right, we're not actually deploying the API. So without even releasing it, we're able to test how it could perform in production, right?
Correct. Yeah. So as long as you give us some sort of description of the API, and this is during development, so it's not deployed yet, we talk to that endpoint that is being deployed. So it's running somewhere, let's say as an alpha version internally on the testing environment. Then we can reach out to it and sort of validate its API security posture.
Really neat. What's this feature called again on Noname security? What's the name of the feature?
So the testing module is called active testing.
Active testing. Okay, cool. So viewers, you got to check that out if this sounds interesting. It definitely sounds interesting to me and I want to read more about it. So active testing. So yeah, I want to also talk a bit about, so a lot of the APIs these days, they're hosted in, cloud services like AWS API Gateway and these services, they have some language around, security and all of that, So I want to just ask you, what kind of security are they talking about and how is it different from the API security solutions that they provide? And in other words, is having your APIs hosted in AWS API Gateway enough for security, or is that not adequate?
Right. So I think even the old security adage of you can only secure what you can see is sort of valid, meaning the gateway has a lot of security capabilities built in, and it can protect against certain types of attacks. So it can enforce things like the usage of specific patterns and so on. But again, the gateway can only see the traffic that passes through the gateway. So back to that finding up to 30, sometimes 40% of unknown APIs inside a given environment, that is something that gateway device will be blind to. It won't be managed via the gateway. The other thing is unknown attacks. So a gateway is also very good at doing signature-based security, so blocking something that passes through the gateway or enforcing a certain level of encryption for tokens, for example. But how do you employ that type of checking if the application that you're protecting is sort of unknown? So if you can't even predict the sequence in which these API calls are done through a specific API, or if you have more dynamic APIs like GraphQL, for example, it's very hard to implement static security checking against those dynamic environment. So that's why you still need a system that really understands the business logic that is used with those APIs. And in our case, employ machine learning to establish a baseline of normal behavior for those APIs. And once we have a baseline, we can start to find outliers that deviate from that baseline, which are an indication of somebody is trying to do something malicious, is trying to manipulate how the API is normally accessed or normally used, and that's what we will respond to, whilst still talking to the API gateway in Amazon, for example, and asking the gateway to block certain traffic. So it's not that we're gonna advocate for replacing these tools, because these tools, they have a lot of value, but it's more about giving them context and showing them all of the API security pieces that they're missing by augmenting what you already have.
Okay, Yeah, that's great. That's a great point. So to summarize this response, I would say, AWS API Gateway and other services like that host APIs, they don't have full visibility into traffic, and you need a dedicated API security solution to get that end-to-end visibility into traffic. That's great. And I want to dig in a little bit more about what you're talking about, machine learning. If you could, it sounded really interesting how you're talking about it detects anomalies. If you could just explain a bit more to the specifics of how Noname uses machine learning to, detect API security threats using, machine learning.
Yeah, absolutely. So from our end, we use unsupervised machine learning. So the idea is that we are put in certain environments where we do not want to rely upon some sort of external data lake or something like that to validate API calls.
Mm-hmm.
That's why it's unsupervised, because in a lot of the, let's say, environments that we're put into, we are sort of in an offline data center, for example, and we don't know what the application looks like. So the system has no baseline of information that we can use to figure out if this is normal behavior or not, meaning for each and every API individually, we're going to have to learn what normal looks like.
Mm-hmm.
So we're going to have to build that baseline. So that's why we use unsupervised machine learning. You put us in the environment, it takes us a couple of days, depending on how heavily is the API used and so on. It takes us a couple of days to build this baseline of what we feel is normal activity and normal behavior. Once we have that baseline, new API calls are validated against that baseline. And then if we see things that are different, we will respond. So for example, let's say you have an API where you can query user data. And typically what we see is that a user logs in and this user only queries his or her own data. So it only reads information from its own user account. Then after the machine learning has created that baseline, somebody logs in with a single user credential and starts to query user details from a lot of different users. So we will then respond and say, this is not what we were expecting here. For us, this looks like malicious traffic, because normally a single user doesn't perform this type of operation. An administrator might perform this type of operation, but normally a normal single user account won't. So for us, that's then a deviation from the baseline. So we will respond to that, show our customer that there's a potential malicious use of the API, and then show them a remediation step, and at the same time block that specific user by removing their authentication token, removing an IP address, depending on how we can identify that specific user.
Very cool. I like how it doesn't just alert and spot it, but it also proactively blocks. So, this could happen in the middle of the night when no one is around, and to take action, and you wake up in the morning and that something's been quarantined, something's been blocked, and you can analyze and see what's the threat there. I think that's really cool. That's really powerful. Wow, that's amazing. So I want to ask about the role of open source and API security. Do you see anything interesting happening in the open source space? Open source is quite powerful today. A lot of companies use them alongside the commercial solutions as well. What do you see in the open source space?
Yeah, I think the open source solutions are super interesting and could be super powerful. So for API specifically, there's a whole bunch of interesting open source tools out there. It starts from linting tools to validate your code, for example. So you upload your API description, and then those open source linting tools, they validate your code, they validate your input, just to make sure that you're not putting undeclared variables out there, etc., which can then potentially be misused during an API attack. So they help you write to a specific level of secure specification, if you will. But there's also open source pen testing tools that are good at finding static security issues. There's also API learning tools to understand or to help you understand like security aspects of an API in a mock environment. So there's, for example, the crappy API tool, which is sort of a playground where you can test against this vulnerable backend API and see how much damage you can cause. So all of these things are very helpful in understanding and learning about APIs and API security. There's a nice list out there on, I believe the website is nordicapis.com.
Okay.
So they keep a fairly up-to-date list of a bunch of open source tools that you can try out and play with, which I highly recommend. Yeah.
Neat. Nordicapis.com. Awesome. As we wind down, my last question for you, what are you most excited about in that's happening right now in terms of API security, whether it's from Noname itself or just in the ecosystem generally? What are you most excited right now, or what do you most look forward to in the coming months in terms of API security?
Yeah, I think from a where the field is going perspective, Gartner has sort of pointed out, and they've done this a number of years ago already, that this year is going to be the year where API attacks will become the most frequent attack vector, and we continue to see proof of that. I'm not saying I'm excited about an increase of attacks, but it does mean that there's an increase in people hearing about this and putting emphasis on it and trying to close these gaps before they become really problematic. A lot of work to do in educating the market still and implementing some of these controls. Another thing that I'm excited about is we use a lot of machine learning in our platform already. The thing that we see is there's a real shortage in staffing up your security personnel. That's becoming really problematic. So I'm excited about the potential of artificial intelligence and AI ops in particular to sort of augment some of the security gaps that are out there and sort of using these big data platforms and so on to help people understand really the influx of all of these logs and all of these tools that are generating all of these events, to really filter through that and really understand holistically what is going on with their security. So I think, I'm excited for AI ops to sort of start to really shine and help people implement good security best practices.
All right. Great. Thank you so much for sharing all of those insights. It was really interesting to hear your take on API security. And I want to encourage our viewers, if all of this sounds interesting that Filip just spoke about, head over to Noname Security's website and check out their offering and see how they help with securing APIs and all of these things that Filip just mentioned, the use of machine learning, the ability to test before you deploy, active testing, I think. Check out all of these things on Noname Security's website. So that comes to the last segment, the fun segment where we get to know a bit about Filip. So we have a couple of questions for him. So Filip, you set? You ready?
Yep.
Cool. So this question gets some interesting answers, and I love asking this. Your alternate career path, if not for your job in tech?
Yeah, so I think it's tech adjacent though. So I would love to work in the commercial space exploration industry. So things like SpaceX or Blue Origin, for example, that would be super interesting. Unfortunately, because they work for the US government, they only accept US citizens or people with green cards. So it's not going to happen soon. But yeah, that would definitely be my career path if possible.
Yeah. Do you dream of someday, like, setting foot on Mars or something? You have those kind of dreams, or are you more interested in just building stuff and working with the tech?
Definitely the building part. Yeah. I would love to be involved in making that happen for somebody else, but it wouldn't be me that's going to to populate Mars. No.
Neat. You're the safe one.
Yep.
One thing you're a pro at, you're an expert at, could be a sport or a hobby or a skill.
Yeah. So I would say like 20 years and 50 pounds ago, I used to play semi-professional basketball.
Okay.
I'm based in Belgium, so it's really semi-professional.
All right, all right.
But yeah, I played basketball in some of the local leagues here, so that's something I still enjoy as an amateur. But yeah, working at a startup, I must say most of my time sort of goes into building out startup organizations these days.
Yeah. Neat. Um, so if you could travel back in time, when and where would you go?
Yeah, I think so. So next to sort of my dream of working in space exploration, I'm also a bit of a physics nerd.
All right.
So I like if I could go back to the 60s and attend like a class at Caltech with Richard Feynman, for example, that's something that I would love to do and love to see in real life. I've seen the recordings, but I would have loved to be there. And if not that, alternatively, like the start of Sun Microsystems, so my first job was working with Sun Microsystems environments, and I would love to have been there in the 80s and work next to people like Andy Bechtolsheim when Sun Microsystems got started.
Wow, you're a true geek at heart.
For sure.
Your favorite tech speaker or presenter?
That's definitely Scott Hanselman. So Scott Hanselman of Microsoft. I've seen a lot of his talks, both recorded and live at things like Microsoft Ignite and so on. So I think he's a really brilliant, engaging speaker. He's also very down to earth. He's also really invested in diversity, equity, inclusion initiatives. He really tries to pull people of all different backgrounds into tech, really trying to push aside gatekeepers, open paths for people. I really love what he's doing, but his presentations and his speaking is just, if you just focus on that, it's also really, really good. So Scott Hanselman, definitely check him out on YouTube.
Really cool. Yeah. Your last question, Filip. Where do you find the most engaging tech conversations happening today?
I think if you're good at curation, Twitter is still a good option.
Okay.
I think Twitter Spaces is also interesting today. So there's a bunch of interesting sort of reoccurring Twitter Spaces that happen on a weekly basis.
Mm-hmm.
One that I'm sort of following is there's one by Brian Cantrill, who is now the CTO at Oxide Computer.
Used to be a giant.
Yeah, so that's a super interesting one. It's a nerdy hangout, I would say. Yeah, that's something I would recommend. And then if you're into like one-sided conversations, then of course there's a lot of super interesting podcasts that you can consume and sort of keep abreast with what's happening in the industry.
All right, cool. Twitter Spaces, I should check that out. Awesome. So that's a wrap. So Filip, if you could tell us where we could find you online, yeah, that'd be great.
Yeah, you can find me on Twitter. So I'm at Filip V, Filip with an F, on Twitter, and I'm also pretty active on LinkedIn. So if you just search Filip Verloy on LinkedIn, I'm sure you'll find me. So those are the two places I'm most active at.
Awesome. Great. So that's it, viewers. Thank you for tuning in again. And I hope you really enjoyed this conversation with Filip. Do check out the other interviews we have at amazic.com. That's AMAZIC. And we've got a whole bunch of stuff as well. Apart from interviews, we've got job listings and event coverage, a lot happening. So do go to amazic.com and follow us and stay tuned on what we do. With that, I'd like to thank Filip again for joining us. It was a pleasure, Filip, talking with you today. And
pleasure was all mine. Thanks for having me.
Yeah. All right. So that's about it for today. Signing off. Thank you.